Hey, what's up guys? Dave here from CNC3D. Today we're going to be having a look at some recent updates that we've pushed through to our CNC3D Commander software. We're going to be taking a look at some of the new features that we've put in there. We'll be going over some features that some of our existing users may not know are already in Commander, and we'll just do a quick recap of some of the standard settings and features that have been there for quite a while. So let's just go ahead and jump straight into it. The first thing that we're going to do, we've just got a standard GRBL based controller connected up to our computer at the moment here, which is currently sitting on COM3. So let's just go ahead and connect to it. Now you'll notice that all of the options are now fully enabled now that we're successfully connected to this GRBL 1.1F controller. So let's just cover some of the key features. On the left hand side here, we obviously have our machine coordinates and we have our job coordinates. We have some standard features that you'd expect in a sender, for example, easy homing of your machine, the ability to travel back to 0 on X and Y job coordinates, the ability to set the actual X and Y and Z values for the job coordinates without moving. So for example, if we set this to 20 and we'll set this to 10, and we can set this to 5, it will automatically update these values without actually doing a travel. So if you do need to set any offsets, you can use the set job function in order to do that, and that should get your job positioning where you need it to be safely. Now you also have the option here of very quickly just zeroing out these values by hitting the 0 job button. For most people that are using either easel or depending on the post processor in the CAM software that you use, usually they do reference the job 0 position, and generally when you jog the machine to where you'd like the job to start, you always just have to remember to hit 0 job before you actually begin running the job. Or some of the senders out there, or some of the G code that's set, will actually ask the machine to travel back to 0 first before actually starting the job. So it's a handy little button to have there if you ever need to set the 0 of your job. Now you've got your standard jogging and navigation buttons over here, and probably one of the most overlooked features that our Commander software does have is this little button in the middle here. And if you have a look, we've got a little keypad jogging system. You can see what the values were there. We've basically set up the ability for you to jog the machine using a standard gamer style WAD system, where WADS will jog the X and Y axes and E and F will jog the Z. And the easiest way to use this feature is just to click on this button so that it's in green, and then we can basically use, say for example, if we hit W, our Y axis will move forward 1 mil. If we hit the A key, then our X axis will go -1, and so forth. And then E will obviously jog the Z axis, and F will jog it back down. When you're done with the keyboard jogging, you can just click on the button again, and that will disable keyboard jogging for you. Now we have some new features that we've added in here. We have this new My Buttons section on here. If we click on this button, you can see that we've got these 3 buttons that we've already set. This tool is basically designed for you to very quickly and easily set up buttons for functions that you may want to execute quickly. We've got this handy little on top feature that will actually keep this window on top of the main window, so you can access this even while this main window is minimized. And then obviously to set this, it's very simple. All you really need to do is just right click on one of these buttons, and you can choose a button text. So say you wanted to set this to home the machine, and then we can set the command to be $H. Now you can customize these buttons if you'd like. Where you've got this back color value, you can just double click on this color, and then we can choose a different color out of this list. And then you can set the text color as well, so that you can fully personalize these buttons. And once you're happy with the options you've chosen, just go to update, and then you can see that your button's in here. And if you ever need to edit any of these buttons, simply right click on them, and then you can change what those values are. Alright, so that pretty much covers the new My Buttons section. It has been a very, very requested feature. So if you do want to set your own custom buttons and do things very quickly, this is a good way to go about it. So let's just hit close on here now, and we'll take a look at some of the features that we've now got in the run job section. So if we choose to load a job on here, so we'll click on load job. We've already got this Alloy Clevis file in here, so we'll just open that. Now you'll notice that the rest of these buttons on the right hand side have now become active. So the first button that you've got is the configure button. So a few users have requested us to add some options in here regarding starting the job and how you'd like to do it. Obviously the most important thing is you can choose what line in the job you actually want to start from, and obviously you've got some starting options here, so you can choose use current job position, 0 job position at the current position, move to job 0 on X and Y, and of course you can choose to home the machine. So these commands will be executed first before the job is actually started, and then it'll go through and proceed with the rest of the job. So once we hit update on here, as you can see, it's loaded this file on here, and it says starting from line 0 at current job position. Now we also have this handy little tools button in here. This particular file does not have any tool changes in there. We are working on some Fusion 360 and Vectric post processors that will basically allow you to do multiple tool changes and actually execute them on a GRBL based controller, which we actually manage internally within Commander itself. So if you do have a job file that does have a standard output with regards to tooling information and it issues T commands, we'll actually intercept those T commands, and then we will actually give you the option of choosing what it is you want to do before choosing to resume your job. So this is a handy feature for those people who may want to, say for example, run a surfacing operation on some alloy, and then obviously go back through and cut the job out using a 1 flute upcut end mill, and then you may want to do another tool change to a chamfering end mill. You could essentially bring all 3 of those tool changes into the one job file, and we'll simply see the T command being executed on our end. We'll get that tool number, and then we'll give you the option of choosing what it is that you'd like to do before resuming your job. So we'll just close out of here for now. You of course have your handy little job view function. So if we click on here, we can see it's loaded up our job. We have some standard options for you to be able to turn and rotate. You can also select using like a rectangle for you to be able to view, and you can also wind your mouse wheel in and out to adjust it. If you want to step through, you've got this handy little running man at the top here, so we can basically just drag this through the job, and you can see every single line of G code as it travels through and runs this operation from start to finish. If you want to, you can reset it back to the middle. We have a couple of options here for a standard view if you just want to look at it from the top, or if you wanted to go to the right side, and you can actually see all of the passes that are going through as it runs through the job. Now we haven't currently set this up to work while the actual job is running. We are looking at shifting the entire logic for this into a OpenGL or a DirectX platform. At the moment we are simply relying on GDI based drawing in order to do this, so we don't think it's suitable at the moment for manually running through while a job is running, but that is coming in the future. So we'll move on now to obviously the run job function. We have loaded the actual job in here at the moment. If we were to hit run job, it's just going to run through and obviously do this job. So we'll just hit run job, and as you can see, it's just running through all of the lines of G code on here. We'll just go ahead and just stop this job, as it's just a theoretical thing that we're doing at the moment. And let's have a look at some of the other features that we have here. Now as you can see, our controller status is currently in alarm. A lot of people don't know that you can hover your mouse over here if it's in an alarm or an error state, and it will actually tell you what the alarm or the error is. What you can also do if we issue another command, so say for example we'll get this to jog, you can see here if we go into our data log, we have all of these commands have executed correctly because they have a green tick next to them, but this one down the bottom here does not, and it has thrown an error for us purely because we are currently in an alarm state. So if we just simply hit unlock, this should go back to idle, and then we should be able to go through and do our normal executions. Now we'll have a look again. This is a bit of an old feature, it's been in here for a while, but just to cover some of these details, in our macros section we can pretty much go through and set up macros in order to run. So if we were to, say for example, put some data in here, and we'll issue a H command, and then we'll do a G90 G10 X0 Y0 Z0. You can basically load up any amount of commands in here that you'd like, and then you can actually execute it as a macro. Once you've got this macro saved, you can just hit save new, and we'll just choose a character for this. So we'll call this test for video. And then basically we've got our, obviously this is an existing test macro that we've saved in here, and if we click on here we've got our other macro loaded. And if you want to run this macro, it's very simple, you can just hit run. For those of you that want to actually record a macro, so if there's a sequence of events that you want to do, we can just hit record here. And we can then go ahead and start loading up some commands for it to do our motion. When you're happy with it, you can just hit stop, and it will prompt you as to whether or not you want to save this macro. We'll just say yes to this, and we'll call it test macro. And now we have our macro in here that we've just recorded. So this is a really handy feature for those of you that may want to perform a particular sequence of events. Hopefully it should be handy and useful for someone. You can obviously choose to, say for example, modify this value here. So say we change this feed rate to 5000, you can hit update and it will automatically update this value in here. So let's move on now to our offsets tab. So these are basically the general offsets within GRBL. You've got all of your standard job coordinate planes from G54 through to G59. You can also choose to set the current value of G28 and to G30, and you can basically choose to set them to whatever you'd like them to be. So the options are really yours. If you do make any changes, just hit refresh offsets, and that will repull the offset data that is currently loaded onto the controller. Now if we move over to our profiles tab, you'll see in here that we have a list of factory machine profiles. We're always looking at adding more in here, so if you've got a particular machine and you've got it dialed in correctly and you'd like for us to add a factory profile for that machine, please feel free to reach out to us either on our website or via email at solutions@cnc3d.com.au. And what you can do is simply save your local machine profile. So if we hit save here, and we'll say yes, and we'll call it my machine. Whoops. And then what you can do is you can click on my machine, and you can basically do an export of this, and it will save it as a profile. So feel free to send through your actual profile for your machine, and we can look at adding it into our system as a factory profile. Now you can delete your user generated profiles, but you cannot delete a factory profile. So they will always stay there. We may look at updating them in the future if there's anything that we've missed, or if you acknowledge that something is not right, then basically we can go through and fix that in the next update of Commander. We've also added a handy feature. There's a new view button on here. If we click on view, it will actually tell you what all of the settings are within that factory profile. So in case you're not sure about something, all of your values will appear in here. So let's move on to the measurements tab. This particular function is basically used for setting up your machine and your steps per millimeter. Generally, it's only done when you first set up a new machine, or if you've built a new machine or made a modification. You may need to adjust your steps per millimeter for your drivers and for your actual drive system. We have tried to make this as simple as possible. We've got this basic step calculator on the right hand side where you can choose, for example, a screw driven or a belt driven setup and choose the micro stepping, and then it will give you a suggested amount of steps for that. If you're obviously running at 1/16 micro stepping, those values will change and you can easily update the numbers in here. Now, if you want to go ahead and actually tune your machine and actually dial those figures in correctly, we can click on Tune here, and we've got our handy little axis test in here. So the first thing you can do, you can obviously jog your machine to give yourself a little bit of safety. Make sure you've got at least 250 mil of clearance, and then once your machine is in a safe position, we can go to step 2. Now there's two ways that you can choose to do this. You can either choose to attach a pencil to the side of your axis and let that run along in order to draw a line on there that can be measured. Alternatively, we have added a M3 option for users that have a laser. So basically what you can do is get your laser to draw a line for you, and then you can easily measure that line. So once you're done, you can go to step 3, and then you can choose to run the axis test for the y-axis and then the x-axis. So once that completes, all you really need to do is measure the line that you've created on the y, and let's assume that it came out to be 198.5 millimeters, and the x-axis came out to be 201.3. You can hit complete test on here and it will automatically update these numbers for the x and the y, and then all you need to do is just hit update measurement settings, and that will send through these values through to the controller. So these two buttons do exactly the same thing. We've just put 2 in there to make it easier for users to understand that they can do both axes in the one go. So hopefully that should be handy for some. Now we'll move on to our axes tab, and this is pretty standard sort of settings within GRBL. We've just simplified this for people. So you can essentially choose to invert any of these axes. You can choose to set your acceleration and your maximum speeds for each axis, and then you can choose to update these values. Make sure to always hit these update buttons if you do make any changes here, just to make sure that it will definitely accept that. You will always receive a confirmation when you change these values. If you don't get a confirmation, it may mean that your controller is currently in an alarm or in an error state. So just make sure to check this controller status over on the left hand side here, and you can obviously choose to hit the emergency stop and unlock to return it back to an idle state, and then you'll find that the commands will probably execute correctly. Now in our peripherals tab at the top here, this is where you've got your options regarding homing, obviously the ability to invert your homing direction should you require on each axis. You've got your standard information here on your homing feed, your homing seek. Basically all of these values will sort of dictate how your machine will perform. Some people with larger machines, they may want to change the homing seek to say 1000 or even 1500. The homing seek is what occurs when you ask the machine to home and it's first looking for that limit switch. It'll actually travel at that speed until it detects that it's hit the switch, and then it will back off the switch, and then it will approach the switch again at the homing feed rate, which is currently set to 25. And then obviously the debounce in milliseconds is basically sort of like a buffer, just to make sure that when it first contacts that switch while it's traveling towards it, sometimes the switch can snap on and off very quickly. This is a bit of a protection for that. Leaving this value at about 250 is typically ideal. Now for the smaller type limit switches where we've got our homing pull-off, that is the distance that once it contacts that switch, it'll bounce off that distance just to make sure that the switch has been depressed. So pretty much 3 mil usually works for the smaller roller type limit switches. If you've got larger limit switches or an inductive limit switch, you may be able to increase or decrease this number as you need to. So let's have a look here. We've obviously got our soft limits down the bottom. We do recommend using soft limits. In order to use soft limits, we have to enable homing. So yes, we'll enable homing, and then you can set the maximum travel distances for each one of your axes if you prefer. Alternatively, you can choose to disable soft limits and enable hard limits, and then all you need to do is choose the hard limit type. Now, as you can see at the moment on the left hand side here, you've got your limit trigger statuses for X, Y, and Z. They're currently green. We don't have any limit switches connected up to this particular machine, so this would be the correct orientation. If we were to change this to normally closed, and we're going to untick this now just so we don't throw an error, you can see that they're all in red now over here. So what we want to do, if the triggers aren't pressed, we're just going to leave it as normally open. Now for your probe, typically most probes are normally open. They do require you to make a physical contact between the tool and the probe, but for some people that may be running an opto-isolator on their input for their probe, you might need to change this to normally closed. Obviously, without the probe being activated, we can see that probe is now lit up over here. So we know that we have to leave this in normally open. Moving on, we've got our cornering section here. These are pretty standard features within GRBL. We have added these in here just to make sure that people can configure their machines correctly. You're more than welcome to click on any one of these links, which will take you through to the GRBL website and explain a little bit more about what the junction deviation is and the arc tolerance. We don't really need to cover that here. Now we go to our operations tab, and there's two types of connections that you can have, or two types of settings that you can have your controller in, and they are either operate using spindle or operate using laser. If you are choosing to run a laser job, we would definitely recommend setting up the laser mode on here. Now, this has been a little bit confusing for a few people. There is a maximum speed and power, and there is a minimum speed and power. Now, this particular number here does not relate to how intense the power output will be, but more what kind of resolution you will get on the actual laser. So, as in, for example, leaving this at 1000, if we sent a M4 and then an S255, you'll actually find you'll be running that at a quarter of the power, and then the maximum value will become 1000. If you leave this value as 255 and leave your minimum at 0, you can just hit update operation settings, and that will now save this, which means if you issue 255 as your maximum spindle speed, then 255 will be 100% power of the laser itself. Now, most of these values down the bottom here under signal processing, they don't really need to be touched in most cases. We have put some recommended values here. The step idle delay simply relates to how much holding torque is applied onto the motors when they're not in operation. If you'd like, you can look up the GRBL documentation to learn more about this, but as a general rule of thumb, you pretty much wouldn't change these values from the standard. Now, in the Connections tab, this doesn't actually apply to a standard GRBL controller. Instead, it applies to our Nighthawk CNC controllers, which at the time of this video, we are getting ready to launch very shortly. Obviously, you can choose to set up your connectivity options on there, but we'll talk about the Nighthawk controller in a later video as we near the release of the product. So some of the other cool things to probably take a look at in here is we've got this handy little create button at the top. So if we click on the create button, we've got two different options in here. We've got a laser image engraver, and we've got an SVG to laser/plasma option. The first thing that we'll do, we're going to go into our laser image engraver, and we're just going to choose to load up a file in here. Let me see if I can find one. There we go. And so what we can do is we can choose to adjust the output of this. It's a standard raster laser engraver, which means it will pan line by line in order to create our drawing. It supports a grayscale output if you'd like. As you can see down the bottom here, we've got our output size as 100mm by 92.34 at 0.2 resolution. We can go up the top here to scale, and we can choose to adjust the width of this. And we can now see that our output is 50 by 46.17. You can choose to remove this lock ratio option on here, and then any changes that you make will only affect the one size. Now we have the option of you to be able to obviously rotate and flip these images. You can also choose to invert the colors completely if you really want to try something totally different. You can then choose to go to the power option at the top, where you can choose the minimum output power and the maximum output power. You have your mode, which can either be grayscale or a dithered effect. We are working on making the dithered effect a little bit better, but for the most purposes, most users will use a grayscale output. Now we have added some color adjustment tools in here, so you can adjust your brightness up and down. You can choose to adjust your contrast to get a different effect, and you can also choose to adjust the overall gamma of the engraving itself as well. Now you can choose the feed rate that you want to travel at between say 1,000 or you could do say 3,000 in here. And you can choose the direction between diagonal engraving and horizontal engraving. At the moment, we do only have diagonal engraving enabled. So if you do an output as horizontal, you may find it is diagonal. That is already in the works to be fixed in the next release. But for the most part, most users typically do a diagonal engraving. And then obviously all you have to do now is just export your G-code. So let's just go to our NC files over here, and we can save this here as car laser engraving, and we can choose to export that file. Just be a little bit patient with this one. Sometimes it can take a little bit longer for it to load. Okay, perfect. So that's now saved. And then what you could do if you wanted to is you could go and load that file here under the Run Job tab of Commander. And then you could choose to run this laser job. So once you've created the file and you've saved it, you can just load it up using load job, and that's pretty much the easiest way for you to start a job. So we'll go back into our creation tools and we'll take a look at our SVG to laser/plasma engraver. So the first thing you need to do is just load a file into here. Let's choose an SVG file that we have on this machine. So we're going to choose our CNC3D logo here. Now you've got a couple of options that we've put in. So obviously you can choose an offset from 0 where you want to start from on X and Y. You can choose to adjust the output size of this engraving. So say we make that 100 mil, and it will automatically adjust on here. Now we do have this scale correction option here. If you click on this button, it'll explain what it does, but essentially what it does is we've noticed that some laser engravers, despite the steps per millimeter being set correctly, they can come out sometimes 9 or 10% bigger or smaller in their output. This is a quick way for you to just adjust the size. Obviously you could adjust the X and Y size over here, but just to make it easier, we have adjusted this little scale correction here, so it will automatically do that for you. Now we've obviously got your standard options regarding feed rate. We've got our spindle torch on command that you want to use, and basically this is a choice between M3 or M4. If you're in laser mode, we definitely recommend running an M4 and not an M3. You can choose to turn the torch off using an M5, and then you can choose the output power for the job. Now one of the new features that we've added into this is the multiple passes option. So you can now choose how many passes you would like to do of this job. So you could say, for example, choose 10 passes. And we've also added a handy feature for machines that do have a Z-axis attached to them. You can also choose to adjust the Z-axis up or down, and you can choose the depth or the height that it will vary per pass. So if we're doing 10 passes and we've set this to 1 millimeter going down, every pass that it performs, it will drop the Z-axis 1 millimeter. Just be careful, obviously, if your laser has a particular focal point, that you definitely do have the clearance in order to be able to drop down to that height. We've mostly added this feature in here because sometimes when people try to use their lasers for cutting, they pretty much need to As they go through and do a pass, it'll go part way through the material, and then you really want to drop that down a little bit just to make sure that you are actually able to get the same focal point through the actual depth of the cut. This might be a little bit of trial and error, but it's really handy that you've got the option to do it. Now, if you are choosing to set up a job for plasma, we have some standard functions in here. For example, you've got your pierce time, so that's when it first reaches a shape. It will pause for X amount of seconds before basically proceeding through the rest of the cut. You can then choose to get it to, so after arc end delay, so when it turns the arc off, it will pause for a bit, and you can also get it that before arc end delay, how much of a pause you would like to have. Most people generally leave this at 0, but for example, if you're cutting thicker steel using your plasma cutter, you may want to just allow it to sit there and just blow a little bit of free air after the arc ends. So you do have those options. If you're happy with that, you've obviously got the 2 different saving options. We'll just save this as laser G code in our NC folder in here. And so new laser job, we can save that one. That's been successfully saved. And you can also choose to, if you want to, save your plasma job right now. And you can save both of those at the same time. So we'll just close out of here. So that pretty much covers our project creation tools. We are looking at adding more here over time, and hopefully very soon in the future we'll have some standard milling operations added in there as well. So we'll just close out of here for now. Probably one of the other things as well that we should cover on here is you've got your standard immediate overrides that you can choose to adjust and change if you want to. So these can happen while you're running a job. You can just choose to set them normally. It's really up to you. And you've got your standard spindle on and off controls over here, so you can choose to either issue an M3 or an M4, and then an actual spindle speed. And of course you've got a manual command function. Now, one thing to note here is some users may not actually have in their buffer on the left hand side here, you may not have the buffer showing up as a percentage. In order to get that buffer to show up, in most cases you can click in this manual command box. We can put a $10 equals 3 and send that command, and that will show this buffer value on the left hand side along with your feeds and speeds. So that's been a really common one that we've had lately, and this is a really good solution for getting that to work. For those that don't know, $10 in GRBL is the reporting function, which basically when we poll the controller, their controller will actually give us all of the information that it can based on what that $10 value is. So $10 equals 3 seems to work really well. If you also notice within Commander that your machine coordinates and your job coordinates are just sitting there on 0, they're not actually giving you values, they're not updating when you click any of the buttons, then sending this $10 equals 3 will resolve that. Let's have a look at some of the actual settings within Commander that we can do as well. So to access these, we just have to hit disconnect at the top, and then we can click on settings. Now, the baud rate option in here is pretty much standard across GRBL. If you do have something fancy and you might have a special controller, you can choose to operate it at a different baud rate if you wish, but 115/200 is typical for most GRBL controllers. We do have the option here of a connect delay. Essentially, connect delay pretty much just applies a millisecond delay when it first connects to a controller, just to give it time to actually start up. You also have a command delay. We would typically recommend leaving this as 0 milliseconds. Otherwise, every time you issue a command, if it's too slow to go to the controller, if your machine's cutting through an arc, it might go a little bit slow. So just leave this at 0, but this is a handy tool just for testing. If something's not right, for example, if you're operating in a noisy environment, you might be able to prove whether or not it is in fact the noise or whether there might be something else going on. So a handy feature for that. Now, you've got the option underneath here for your serial communications. We've done quite a lot to the serial communications. So when you communicate via USB to your controller, you can choose to run asynchronous, which is recommended, or you can choose to run synchronous for data issues, which may resolve some issues with Commander freezing or not sending commands. But for the most part, just leave it on asynchronous and you should be fine. Now underneath here, we've got send immediate commands asynchronously. If you have the asynchronous option chosen here, they are going to be asynchronous anyway. Whereas if you go synchronous in here, then it will still send immediate commands asynchronously, which means they won't go into the command buffer and then be executed. They're still just going to go straight out. Now something handy that Commander does have, and this is probably a big point, is we also support a fourth axis. So if we tick this box here, show fourth axis, then we can actually display all of the details we need for the fourth axis, but we'll cover that in a moment. So underneath here, we've got a double buffer data log. So what we've done is our data log, typically when it's sending lots of commands, it can flicker while it's running if this value is not enabled. It is much smoother if it is ticked. Some other computers that have less processing power may struggle to update this buffer. It may make it a bit difficult for you to get to other tabs. So we have given users the option of changing this. So we'll just tick this option anyway. And then now under here, we've got our keyboard jogging distance per key press. So this is really simple. Basically, for your X and Y and your Z distance, for every time you press the key when keyboard mode is enabled, so if we press W, that would travel the Y plus 1 millimeter in this case. And it will also do, if we hit D, it will also do your X plus 1 millimeter per key press. And then it will give you the feed rate that it will actually travel at here for both X, Y, and Z. So let's say that we're happy with these options now. Keep in mind we have our show fourth axis ticked. You can see that we now have our fourth axis listed in here. So if we go back through and connect to this controller, okay, so as you can see here, we now have our 4 axes enabled on here. So we currently have our A axis showing as well. Now this particular controller is only a 3-axis control, so it will actually throw an error if we do try to set this. So we're not going to hit A minus or A plus for now, but you'll also notice as we go through some of our options on here, we actually have our A axis values and steps per millimeter showing up. And you also have your A axis maximum acceleration and maximum speed. And we also have the homing options for A showing up in here. So it's very easy for you to go through and set up either a rotary axis or whatever else you're choosing to use as an independent axis. All of the general and basic settings can actually be set for these. Now with this being a 3-axis controller, it will throw an error if we try to update these settings. At the moment, the 4th-axis control or 4-axis control currently supports the GRBL Mega 5X project and pretty much should actually work with most other 4-axis GRBL based controllers, so worthwhile giving it a try if you do have a 4-axis controller. Down the track we may look at implementing a 5-axis version, but for now having 4 axes is pretty helpful for about 95% of users, but just leave it with us and we'll definitely get there down the track. So look, that pretty much covers everything here within Commander. We can have a look here. We obviously have this help button at the top. And what we've done is just to keep things really simple, we've just added some links through to our community forum, or you can join us on our CNC3D Commander Facebook group or our CNC3D Facebook page if you'd like to follow and support us. We also do have the diagnostics for your actual connection. So when you first connect to the controller, it does have this information here. You can easily hit copy all, and then if you, for example, hop onto our CNC3D Commander Facebook group, if you have trouble connecting, you can basically paste that data in there, and then we can have a look and try to work out why your controller isn't actually working or why the software isn't working with your controller. So it's a really handy little feature, this one. We have also added in here the ability for you to choose to donate to us. Look, you don't have to donate to us, to be honest. We spend a lot of time working on the project. We have made it free to all users. If you think it's worth something for your time, you're more than welcome to give us a contribution. If not, that's perfectly fine too. You can just continue to use it, and we'll keep adding cool and exciting features to it. I think that pretty much covers everything here today, guys. If you like this video, please remember to like and subscribe to our YouTube channel, and please follow us on Facebook for any updates that we may have going. Thank you very much for your support, and we'll catch up soon. Have a great day.